Good morning. Welcome to session 406, Integrating Swift with Objective-C. Now, many of the Swift demos here at the conference start by creating either a brand new project from one of Xcode's project templates or a playground, and that's great. Playgrounds are a great way to explore the Swift language. But many of you already have Mac or iOS apps, and some of you have spent years writing Objective-C code. You've written it carefully, you've debugged it, polished it, optimized it. It's just perfect. And we certainly don't want you to have to throw any of that away or rewrite anything that you don't want to. Also, some of you have really a lot of Objective-C code that you've maybe spent a decade writing, and maybe it's not so perfect. It's not as clean and shiny. So you are going to be using that Objective-C code for a while. You might want to rewrite it, but it's not going to happen this time around because you've got an app to ship, etc. So Objective-C is not going away. Both Swift and Objective-C are first-class citizens for doing Cocoa and Cocoa Touch development. And in fact, we don't want you to spend any time that you don't have to. We don't want you to stop refining the Objective-C code. We want you to be able to integrate Swift as you want to. And we do think that as you implement new features, as you finally get around to replacing crufty subsystems, that you'll want to use Swift for that because of its better type safety, its expressiveness, its performance. Now, many of you have also gained a lot of knowledge and experience in Cocoa and Cocoa Touch through your years of Objective-C development, and that applies to Swift as well. You use the same frameworks, the same classes, the same APIs with some syntactic differences, and in fact, the same design patterns, such as delegation. So all of that knowledge applies, and so we expect that a lot of you are going to end up with projects that contain both Swift and Objective-C, and we worked hard to make sure that Xcode lets you freely mix Swift and Objective-C. So in this session, over the next hour, we're going to be talking a little bit more detail than what you've probably seen so far about exactly how that works in practice. We're going to start simple by just introducing some Swift code into an existing Objective-C app. Then we'll get a little bit more interesting. We're going to start to add some Swift code to a model-level framework, which is then embedded in an Objective-C app, and call that from Objective-C. We'll talk about how to start accessing a pure Swift framework, which there will probably start showing up from an Objective-C app. And then we'll talk, as we go along, about how to adopt some of the common, well-established Cocoa patterns in Swift. And again, Swift is designed from the ground up to be a great Cocoa Touch development language. And so it has language support for some of the Cocoa idioms that we've gotten used to. So I could go on here for 24 slides and talk in detail about how this works, but I'd rather just give a demo because that's usually a bit more clear. All right. So I've got a project here. It's an iOS app, and it has an embedded framework. So it's decently designed here. It's got the top layer, which is the actual app, with the view and the controller layer in our MVC design. There is a framework called ListerKit down here, which contains our model objects. And all of this is currently written in Objective-C. Just to give a sense of what this is, let's go ahead and run it in the simulator. And we're going to go ahead here and bring up the simulator. We see that, it's a typical list-taking application. I can go in and I have colored lists here. I can check off items, etc., edit them. What I can't do right now is to add a new list. This happens to be an iCloud app, so I could do that in my Mac app, and it would show up here. But for this example, we're going to use Swift to add the ability to add a new list in iOS. All right, so I'm going to go back here, and the first thing I'm going to do is look down here under the group View Controllers. And here we have some view controllers already written in Objective-C. Objective-C. I go to File, create a new file. And in this case, I'm just going to create an empty Swift file because I want to show you how to get started from scratch. Xcode has great file templates and can fill in a lot of code for you. But we want to do it in a basic way here to show how it's going to work. I'm going to call it New List Controller. And I'm going to make sure that it is going to go into the application target here. We also see that I have ListerKit, which is my framework, and one of the new extensions here for showing in the status view. So new list controller. Now, as I create this, my first Swift file in a pure Objective-C project, Xcode will offer to create for me what's called a bridging header. So a bridging header, we'll talk about that in more detail later, but basically what it is a way for you to expose some of your Objective-C APIs to Swift. I'm going to go ahead and create that, so I get that by default. Now, import foundation, I actually am going to be needing some UIKit API here, so I go ahead and change that to UIKit. And I know that I will need to import my own model framework because we want to obviously create our model objects from within the view controller. And I'm just going to go ahead here and say new list controller. And now, when I complete, we see that because I said import UIKit there, Swift pulls in the Objective-C framework UIKit and gives me a Swift view of those symbols. So I'm going to subclass from UI controller and just leave it like that for now. So we have just a basic empty class, a Swift class subclassing an Objective-C class that we get from Cocoa Touch. Now, we could sit here and drag out rectangles and create an API, create a UI for this, but fortunately, I happen to already have one. How lucky. It isn't wired up though, so we're going to do that right now. The first thing I'm going to do here is, just like with Objective-C, I need to set what the class of my UI controller is. So I can go up here, and now we see that the new list controller that I just created is shown here among all the ones implemented in Objective-C. So when you access your classes from Interface Builder, the Swift and Objective-C classes show up next to each other. You can work with them as equals. All right, so now the next thing I want to do after setting that, I'm going to go ahead and create a bar button item here. I'm going to drag that up into the toolbar up here, and I'm going to change the identifier to be add, and that also changes the visual appearance to give it a standard Cocoa Touch add button look. I will create a segue. It's going to be a mobile segue. This is after all the storyboard. And I'll change the name of that segue to be new lists. Now that's going to be important a little bit later on so that we can access it from within our code. Okay. So now, you may have seen in one of the other demos how we can drag from Swift code and connect to objects inside of IB. We can do the same thing the other direction as well. If I option click here on my Swift class, my view controller class implemented in Swift, now I can drag the other direction. First thing I'm going to do is I'm going to go ahead and drag from an outlet and insert a new outlet here. And I'm going to call this name field. And we see that it's a UI text field, and the storage is weak because we have a controller class. The view hierarchy owns the button and the name and the fields and the buttons in here. And so we just want a weak reference to it. And in fact, when we insert this, Interface Builder knows it's a Swift file, so it uses the Swift syntax, just as it would have for Objective-C. And it uses the IB outlet property for the stored property, the IB outlet attribute for the stored property here. And this is implicitly weak and also optional because not all the outlets may be connected. Give myself some space there. I'm going to go ahead and do the same thing here for the buttons. I'm just going to control drag these, and I'm just going to fill these in the same way. Now, this is a sample app. Let me go ahead and adjust the spacing there. This is a sample app, and so it's not very scalable to just have 6 buttons and 6 outlets. But I know that you all designed better, more maintainable code than this. This is for illustrative purposes only. You might want something where you can load colors from a table view, from a plist, and show them in a table view or something like that. I'm going to go ahead and finish connecting these. All right, so now we have our outlets to the UI components. We can also create actions in this way. If I choose the cancel button down here and I drag in, then I can create an action. Up at the top here, just as for Objective-C, I change the connection type to action. I will type here cancel, and we can just leave the type of the sender as any object here. We don't actually care because we're not going to be messaging it. What we will do, however, is to invoke some Cocoa Touch API. Give myself some more room. And I can say self, dismiss, and then code completion gives me access to the Cocoa Touch API that we already know. I can complete here. I'm not going to need I want it to be animated, so I put true. I don't need a completion block, so I give it nil. Now, in Objective-C, we always have to message self if we want to talk to self. Swift knows from context when you are messaging yourself, so we can actually leave this out and make this a little bit more readable. Excellent. All right, so now we will connect the buttons here as well. And I'm going to be calling this pick color. Now in this case, I choose UI button. I'm sorry, I need to make it an action. I choose UI button down here because in this case, we will actually want to talk to the button or compare the button. So we want to have that type. And as you can see, Interface Builder generates the code and makes the sender be a UI button. Before I forget, I'm also going to wire up the other actions here as well. Let me see here. To connect to this one. Give myself a little bit of space there. And now they're all wired up to the same action. So they're all wired up to the same action. The sender will be different depending on which button we touch. Now, I want to show some of the power of the Swift select statement here, the switch statement. Unlike Objective-C or other C-based languages, I can actually switch on a wide variety of different kinds of patterns. In this case, I'm just switching on what the sender is, but this is a very rich construct in the Swift language, and I encourage you to catch one of the later talks about advanced Swift to really get into the depth of what you can use this for. For right now, to keep it simple, I'm just going to use it to match on a button. And what I will say is, OK, now I need to assign something here. So I'm going to need to have a stored property. I'll create a stored property called selected label, because we're actually choosing labels here represented as colors on the screen. And then what I can do here is I can say this is an AAPL list label. So this, again, is an Objective-C type that has been imported through my import of ListerKit up there. I'm going to start out by saying that that is an APL list label .gray. That's the default value of it. Because I don't put a question mark, I don't make it optional, that means that it has to have a value. Remember, the IB outlets are implicitly optional. Now, it's kind of ugly to have to repeat the same thing here. And in fact, Swift has great support for type inference. And when it knows exactly what type you mean, then you can go ahead and leave out the type. So from this, Swift can tell exactly that, OK, this has to be an APL list label, because that's how I'm initializing it, so I can just leave out the type. Now I can complete my statement here. I can say selected label equals .gray. And in fact, I can add the rest of them here as well. I'm a very fast typer. Now, we see here that Objective-C, Xcode, Swift has a message for us here. So in Swift, one of the things to notice is each of the cases is implicitly ended at the beginning of the next case. So you don't have the case of C where you implicitly fall through, and that's the source of a lot of bugs. In fact, Swift was explicitly designed to avoid many of the common pitfalls that are common in C-based languages. Now in this case, another thing about the switch statement is that it has to be exhaustive, so you have to say that you cover all the cases. In this particular case, I'm just going to add a default, and what I'm going to do in this case right here is to use a Swift standard library function to just trap into the debugger, because I want to make sure that if I add new buttons and hook them up, that I actually add the code for that as well. So now Xcode is happy. That's excellent. We've just set our property. That's all we've done so far. But now we can use some more of the Cocoa Touch API to actually make the button show a reflected state, show its selected state, I should say. So we say, in this case, we can say sender dot, and then we can use our code completion to access the layer. And then we'll set its border width to be 5. And then, of course, we have to initialize that to be a border color as well. Now, in this case, because we're accessing the layer, that's a core graphics API, we get the CG color from the UI color. And all of these are standard Cocoa Touch APIs. So you see that when we access our own Objective-C APIs or the Cocoa Touch APIs, it looks all the same. We still use the same nice Swift syntax. Another thing we can do here is to just say that the view's tint color is going to be the color that corresponds to the label. And for this, we can call another one of our functions that we brought in from Objective-C. And we pass it the selected label. And in fact, if we command click on this, we see here that we can get to a Swift representation of our own Objective-C API. And navigate, we could actually go back to the header itself that we declared it from. All right. So now, those of you who are following closely here may have seen a little bit of a problem. We set the border width to 5. We never actually deselect the previous button. So what we can do is to keep track of the currently selected button. And in this case, I'm going to explicitly say that it's a weak stored property. So this is not going to cause extend the lifetime of that button, which is after all owned by the view hierarchy. And I'm going to declare that this is a UI button, but it's optional. Because when we first start out, it has no value. And so we're going to be able to check whether it has a value or not. We add some code to set the selected button to the sender at the end of having assigned it. And then here we can say, if selected button, then we're going to go ahead and clear out the border on that one. Now, this happens to be an object reference, so I could do the same in Objective-C with a nil value. But one of the nice things about optionals in Swift is that they apply to any type of value, even a Boolean or a scalar. So in this particular case, I'm just going to go ahead and set the selected button's layer border width to 0. Now you'll notice the exclamation mark there. This is the unwrapping operator. And that says that if I have an optional value, then when I've determined it has a value, I get at the actual value. And if I forgot to check whether it has a value, that will cause a trap if it doesn't. So this is one of the ways that Swift makes it safer to write your apps, because you can catch these errors earlier without having to add a lot of assertions to your code. So I think we're probably good to go here. Let's go ahead and take a look. And I'm sure I forgot something somewhere. Selected button, and that's because I mistyped it. So that shows that this is live, right? I'm not playing a QuickTime movie up here. Okay, so now we're here. We have our add button. We bring up a modal sheet. As we select the various buttons, we can see that we have the border, and then we do we tint the buttons down here. And of course, the save button doesn't yet work. Now, I'm just a UI guy, so I just make it look pretty. But to actually do the model level work, we're going to ask one of my colleagues to come up here in a moment. First, let's take a look at what we did in this part. OK. So what did we just do? So first of all, we added some Swift code to an Objective-C app. And Xcode offered to create us a bridging header, which the next section will go into some more detail about. We subclassed a Cocoa Touch class in Swift. In this case, it happened to be a Cocoa Touch class that's part of the standard libraries of Cocoa Touch itself, but it could also be one of your Objective-C classes that you've declared. We used Swift class in the interface builder, and as I hope you saw, it's exactly like working with an Objective-C class. And that's actually a theme under here, that we want it to feel like exactly the same thing. It's interchangeable. And so now, to make this a bit more real in terms of the model, I'm going to ask my colleague Dave to come up and complete the project here, or work on it further.
All right, thanks, Anders. What we saw is that you have access to everything in Cocoa Touch and the power that you've got in Xcode from Swift without really doing anything. But I'm sure what you're thinking now is, what about my code? What about the Objective-C code that I have in my target, in my app? And that's what I want to show you. As Anders said, we could spend a lot of time in slides and everything else, and I'm actually going to cut it a little shorter than he did and just go straight into a demo. And so we come back right where we were before. And for our purposes, the first thing we want to do here is a little bit of tidy up. And that is to make our UI text field behave the way that we want for our user. It offers a great deal of configurability using the delegate pattern. And to do that, we're going to make new list controller conform to UI text field delegate, which is as easy as, if I could type, finding our UI text field. Man, I'm having some time here. It's a comedy show, I promise. There we go. All right, something to call out there is success. And that's the hardest thing I'm going to do the whole time I'm up here. So UI text field delegate, all we did here was add the protocol conformance to the end of a comma-separated list after our class. In our case, it's important because we actually have a superclass, that the superclass is the first thing in that list, and then our protocols follow. Now that I have managed to declare text field delegate, I'm actually going to take it easy for the next part and just bring in the implementation of text field should return. And the only thing we're doing here is resigning first responder on our text field and returning to make sure the keyboard dismisses when the user hits return. Not particularly interesting, but it was just as easy as it would be in Objective-C to go ahead and implement this protocol. Next, as Anders promised, we are going to look a little bit more at the interaction with the model side of things and actually implement save. First thing I'm going to do, who caught the error here? Somebody knows what I forgot to do. And that is, managed to declare it as a UI text field delegate, but we never actually connected it. And that would have made for an interesting end. So now that we've got that set up, I will control drag over, manage to get the button. Set it up as an action, we'll call it save. Now, inside here, I actually want to interact with the representation of our documents that we see in the document list on the main screen. And that's a part of our app target, not a part of ListerKit. And because of that, we have to take a different approach. We can't just simply import our framework in. And this is where we make use of the Objective-C bridging header that Xcode offered to create for us when we created the first Swift file in this project. So we'll navigate over to that. And it gets created in the same directory, or in the same group, I should say, as the Swift file that we created. It's not overly interesting at first. It simply has a comment that's very instructive. This is where we put the imports for the classes in our target that we want to expose to Swift. In our case, it's a single class, and that is our list info class. This is the representation that backs the table view that you see when the app initially comes up. Save that and head back to, really don't need the storyboard anymore, so I'm going to go ahead and collapse things down and let us actually focus on the code, because the wrapping really kind of gets on my nerves. It's one of the things I like about Swift is it's a little more succinct. So just heading back down to our save. Now that we've pulled in the bridging header, or now that we've added our class to the bridging header, we can actually create one. I'm going to create it as a let because it's going to be constant. I'm only going to assign it once. And so my list info is equal list info and of course I keep saying list info. Like we instruct you guys to do when we're writing Objective-C code, we actually use a prefix. And I've been writing a lot of Swift code lately, so it's not on the forefront of my mind. So our list info, and it offers us two constructors. One of them takes a URL, the other takes an NS metadata item for that iCloud support we were talking about. We're going to go with the URL one. I could construct the URL right here. A little bit of forethought, thinking forward. I know that I'm actually going to want to revise this a little bit later and iterate on it. So I'm going to set up a computed property as a convenience. Now, to declare a computed property is pretty similar to the way that we define a stored property. And we'll go with var. I'm going to call it file URL. Now, with a computed property, we do have to be explicit about our type. I'm going to make it optional. And that's because if the user actually hasn't provided us a value in the text field yet, I can't actually construct a valid URL. We've got an implementation ready that just happens to make use of the list coordinator from down in the lister kit. And after defining the computed property, I can come down and make use of it right away. And you'll notice, as Anders had mentioned earlier, we don't actually have to explicitly refer to self when accessing our property. Set up a few pieces of information that we've captured for the user. So we'll get the name from our name fields, text, and the label is going to be equal to our selected label. And that looks good. So now that we've set it up, we actually want to save this out, and list info provides us a convenience for that. And we will create and save with completion handler. And this completion handler is actually going to come back to us with a bool letting us know whether or not the save was successful. And I could use what code completion is suggesting here and fill out my completion handler closure inside of the parentheses, but because it's the last argument in the call, and because it's a closure and it's going to be a little long, I'm actually going to make use of Swift's trailing closure syntax. And in this case, I don't even have to put the parens after the method call, because our create and save with completion handler actually doesn't take any other arguments. So inside of here, I will note the variable name that's being passed in, which is success. Have more typing problems so that you guys can get a good laugh. And I'll just check the value. And for now, I'm going to print a little debug message to let me know that it was saved. And just like cancel, we want to get out of the user's way now, so we'll go ahead and dismiss. So let's build and run. See that everything's doing what we want it to do. Make sure everything is good to go. Bring it up. Let's see, I need to go to the hardware store a little bit later. And so we'll name our list hardware, hit return, keyboard goes away, that's a good sign. Hardware store I frequent actually uses orange in the logo rather heavily, so that's going to help me remember what's going on there. And I'll go ahead and hit the save button. That's not really what we wanted. I really wanted to see my hardware list show up here. Did it actually save? I'll go over, check the debug console. Indeed, it did save. And just for fun, I'll actually stop and run the app again, and you'll see that it actually did save and get created. But we never passed anything back to our document list to let it know that we created anything new. And we kind of wanted this to not be sitting there and polling the file system over and over and over again, just looking for new files that might show up. So for our purposes, we're going to take a page out of UI text fields book, and we're actually going to use delegation to pass information back to the view controller that presented us. The first step there is usually to define a protocol that we expect our delegate to conform to. And in Swift, we can do that just as easily as declaring a class or a struct or anything else. We'll just start with the protocol keyword that I actually spelled correctly, and new list controller delegate. And I already have a method that I want my delegate to conform to that I've pre-prepared that just takes a new list controller and a list info, letting it know what's been created and done over here. Now at this point, this protocol is visible to my Swift code, but I want to make sure that my Objective-C code can see it as well. To do that, it's as simple as adding an attribute at obj_c, and this is going to go ahead and say, even though this is all Swift here, we do want to make this available to Objective-C a little bit later on. So now that I have a delegate protocol, I'll actually define a delegate, and we'll make it weak because we don't really want to own it. We don't want to extend its lifetime. And I can declare it as being just of the new list controller delegate type. I don't have to do something like ID and angle brackets around my protocol to indicate what's going on here. I can simply have a property that is of this delegate type. It's going to be optional because I may not have a delegate. So now that we've defined a delegate property, I think maybe we ought to do something a little more useful than printing a debug statement down here. And for that, we're going to reach out to our delegate, and I'm going to make use of another Swift feature, which is optional chaining. So the delegate is an optional. It may or may not have a value. By adding a question mark here before actually calling out to the method that we want to invoke, I'm going to be able to say, if I have a delegate, if there is a value there, make this call. If there's not, don't do anything. And now I'm trying to remember what the name of it was. There we go. Pass myself and the list info that we just created. Really not much of a typist, in case you can't tell. And at this point, we've wrapped up the Swift implementation of this, but we've defined this delegate. Now we actually need our Objective-C code to be able to see the Swift code we've just put together and interact with it. To do that, I'm going to head back over to the document, the controller for the document list. And inside of here, we're brought to, what comes to your mind is the fact that the way I make one object in Objective-C available and visible to another object is by importing its header. Well, with Swift, we don't have headers. We think that's a good thing within Swift, but we've got to find a way to bridge the gap back to Objective-C. And so in that case, Xcode's got our back and is going to provide us with a generated header that contains the entirety of our Swift interface. Being generated, obviously it has to have a well-constructed naming scheme. And that's going to be our product name, which in this case is lister, -swift.h. And so this is a generated header, so I'm going to go ahead and take the time to build to make sure that we've got the most up-to-date items in it. And after importing that, we will come over here and we're going to go through basically the same process that you would ordinarily to implement any of the Cocoa or Cocoa Touch delegates on your own class. We'll add our protocol conformance. and we can pull in our new list controller delegate. I'm going to choose to use the jump bar to head down to an appropriate place, I feel, to go ahead and implement this. And as I code complete here, with the new list controller did create list info, you'll notice that even though we declared this completely within Swift, what we get is a syntax that matches what I'd expect from Objective-C, so that everything still feels natural. Everything feels like a first-class citizen in its place. Happen to have the implementation, well, the implementation of the last thing ready. In this case, what we're really doing is just updating our data source and then refreshing the table view with a little bit of new information. And the very last thing here, the final step, is that we actually need this view controller to make itself the delegate for our new list controller. We're using a modal segue, so why not do it in prepare for segue? Down here, we'll just check to make sure that it's the right segue. We'll grab the new list controller, and we'll set ourselves, in this case, our list documents view controller, as the delegate. At this point, I fully expect things to do what I want. And coming up with another list. WWDC must-haves. Not really sure what those are yet, but I'm pretty sure I'm going to think something up. And this time, it actually comes through, shows up in our document view controller, and just for proof's sake, I can come into it, I can change it around. I really like the salmon color that they're using for the Apple badges this year, so I'm going to actually pick that. And that's integrating our code. And just to head back to the slides for a second, what we've just seen here is that it's very easy to expose our Objective-C code to Swift. Simply import whatever headers you want into the bridging header, and they'll be made available to the Swift in your target. We've defined a protocol in Swift, which was as easy as defining a protocol in Objective-C. And finally, we've exposed that protocol and the class that we just created in Swift back to the Objective-C code in our target, and we actually didn't have to do anything there. Xcode did the generation of the header that provided that interface. So just to reiterate a little bit more, when we want to go from our Objective-C headers and make our Objective-C objects available to Swift, we're going through the bridging header. This is going to be created. Xcode will offer to create this for you automatically when you add a Swift file to an existing Objective-C target or an Objective-C file to an existing Swift target. When we want to get our Swift interface exposed to our Objective-C implementation, there we're looking at the generated header that Xcode provides. And this is going to be named after our product. And it's going to be our product name -swift.h. One last thing to remember about these is that the bridging header is created for you by Xcode, but you own it from that point forward. So it should be something you check into your source control system. It should be something that you maintain, you manage, and it's there so that you only expose to Swift what you want to expose to Swift. In the case of the generated header, it's just that. It's generated as part of the build process. It's going to contain the complete interface for the Swift files within your target, and those are going to be readily available to Objective-C simply by importing that header. So at this point, to talk with you a little bit more about what you can do with frameworks in your product, in your projects, I'd like to invite my colleague Jordan up.
Thanks, Dave. All right, so we've seen how easy it is to deal with integrating your Swift code into an existing Objective-C app. And Xcode pretty much takes care of all the details for you. It's available in Interface Builder. It's going to show up in the simulator. Everything works just fine. So I'd like to move a step down in the hierarchy and look at the framework. So at this point, we've been working pretty much the entire time up in this lister part of the application, which is the actual application target. Now we're going to move down to ListerKit, which handles the model and the object graph for this target. And specifically, we're going to add a new functionality, the ability to add attachments to every list item, something like a photo or a voice recording. To do this in Objective-C, you would create a new class, add it to your object graph by adding a new property, and then setting up an interface to manage it. And we're going to do the exact same thing, but using Swift. So I'll start here by going to File, New File, and this time let's use the CocoaTouch class template. I can name this APL list item attachment, subclass of NSObject, and the language, of course, is Swift. And make sure that it's in the ListerKit target and click Create. You'll notice here that Xcode did not offer to create a bridging header for us. This is because we're working with a framework target. In a framework, you already have a header that specifies the entire contents of the framework. That's your umbrella header. So when you're working with a framework target in Swift, everything that's available in your umbrella header will automatically be visible to the Swift code. No work required. So we're going to want attachment objects to persist. So the very first thing I'm going to do is add a conformance to a standard CocoaTouch protocol, NSCoding. Attachments are made up of two things. Their data, which I will represent using an NSData, and their type. For types of data, CocoaTouch likes to use uniform type identifiers, which are a very general way to represent file and data types. And these are just stored as strings. The next thing to do here is to declare an initializer. And that just takes the data and type from outside and will assign them into our own fields. But we do need to be careful, because the data that we are given might be an NS mutable data, and somebody might try to change it after they've created our attachment. So in order to work around this, we need to call the copy method. However, copy returns ID in Objective-C, and in Swift that's going to come through as the AnyObject type. We can't go directly from AnyObject to NSData in Swift, because that's not guaranteed to be safe. So instead, we have to explicitly tell the compiler to do a cast here. And this is important, because if anybody ever implements the copy method incorrectly and doesn't return an NSData, we would much rather find out about it right here in the initializer than crash somewhere down the line when we try to use it. On the other hand, we can just assign the type directly. And this is because strings in Swift are values. Unlike NSString, every Swift string has an independent existence. And when you assign across using the equal operator, you get independent strings. So whatever somebody does over here to their string won't affect your string over here. So next, I need to implement the NSCoding protocol. Let's close this for a bit more room. And here we can code complete here. No code completion. Awesome. So here I'm implementing the NSCoder's initializer. And you'll notice something a little funny here. In Objective-C, we'd have a method named initWithCoder. But in Swift, we have an initializer that's just initCoder. So in order for more consistency in the Swift world, where object creation syntax is a little different, an init method from Objective-C that starts with initWith will come into Swift with the with dropped. This ensures a consistent world with Objective-C. So here, the implementation of this is pretty much the same as what you'd expect, just called decode object for key, and again, explicitly downcasting to the type we want. If somebody hands us a bad archive, we'll find out about it now rather than crashing later on. Finally, the last thing to do here is implement the encodeWithCoder method. And this one does not get any name changes because that is limited specifically to initializers. And the implementation of this, again, is very simple. We call encodeObject for key with both the data and the type. And that's it. This is an entire Swift model object, and it fits on one slide. I didn't do anything crazy or confusing here beyond some of the things you need to do to be a good CocoaTouch citizen. The next step, of course, is to add this into our object graph. So I go back to our Objective-C header. And now we have a bit of a problem, because last time that we wanted to access Swift code from Objective-C, what we did is import the generated header into the Objective-C file. But we can't do that here because the generated header depends on the Swift. And the Swift reads the entire public contents of our framework via the umbrella header. And that includes this header right here. So instead, I use exactly the same mechanism that I have in Objective-C. This is what we use to break cycles. It's a forward declaration using @class. And I can forward declare the Swift class just like I would any Objective-C class. And now I am perfectly able to create a property here using the attachment. The last thing to do, of course, is to update the implementation of the list item to actually handle the attachment. And for that, I'm going to import the generated header, now that we're in a .m file. And because this is a framework, and the generated header is part of our public interface, we are going to use framework syntax to import it. All that's left to do here now is to update the implementation of this class so that we actually handle this new property. So that means having an extra key for encoding here, setting the attachment explicitly to nil, making sure that we can encode and decode it. And while I'm doing this, I'd like you all to note that this is exactly what you'd be doing if we had implemented the attachment class in Objective-C. There's nothing surprising going on here. It's exactly what you would have done before. Finally, we do need to make sure that we update the copy method so that when we copy a list item, that we actually do get a copy of the attachment as well. Square bracket. And since we made our attachments immutable using that let keyword to define the properties, we can just assign this across directly. We don't need to do any special copying to ensure that they are independent and not going to change on us. So that's it. That's the entire model. And now you're probably thinking, oh great, here we go again. Back to Interface Builder to define a new layout, a new view controller, and add a bunch of outlets and actions and hook everything up all over again. We already saw that. And you'd be right, except that we're actually really lucky here. The three of us work in a department with lots of other great people, and another team is working on a very similar app that needs to deal with these kind of attachments. And because their app is new, they've written it entirely in Swift. But they've also factored out their attachment view controller into a separate framework, which is a new feature of iOS 8. So we're going to use their framework, written entirely in Swift, to implement the interface that deals with this model object. To start off here, I'm going to go to the bottom here and check the plus, yet another way to add new files to our target. Choose Add Files here, and I'll go into the Media Viewer folder to select their project, mediaviewer.xcodeproj. Once I have this in my project, then I can just add this to our target by going to Our Own Project, selecting the list or target, and in the Embedded Binaries section, clicking the plus. This lets us add the framework directly. Notice what we just did there. This is a new feature of iOS 8 to allow embedded frameworks. Of course, if you're a Mac programmer, you're probably used to this by now. These embedded frameworks need to be made available to Interface Builder, to other classes in your project, linked into your binary so that you can actually run it, and copied into the app so that when other people download it, they don't need to download the framework separately. And Xcode 6 did all of that for us without asking if the framework was written in Objective-C or Swift or a mixture of the both. So we're in our storyboard now. Can zoom out, and let's bring up the library here to bring out a new view controller. And in this case, I'm going to set the class of that view controller to be the media view controller from the other framework. And you'll see the module field here populates as well. This is that feature of Swift that keeps different framework classes from stepping on each other at runtime, even without a prefix. We don't need the view that Interface Builder provides for us because it already has one in its own framework. So I can just delete that. And now to make sure that we can actually get to this, I'll select the table cell here. and drag over, control drag, to create a new segue. Make that a push segue, and we'll give that a name, attachment. Now we've set up Interface Builder. We've set up the interface and the model object. It's time to put them together. And once again, we're going to use a delegate for that. So let's go to our Objective-C code. This is the code that displays the lists. At the top here, we have the Notification Center, which is a system framework, and the import for ListerKit, which is our own model framework within this project. I can add a third import for Media Viewer, which is the framework in the other project. I'm going to hit Build again to make sure that everything's compiled and up to date. And now I get code completion for the Media Viewer delegate protocol. Just like before, I'm going to jump down to a nice convenient place in the application to implement this. And the first thing I'm going to do is implement a little helper method here that just returns the selected item. Again, even though this is sort of details of like how the application currently works, I want you to remember that everything we're doing here is exactly what you do in Objective-C. From the perspective of this code, you can't really tell that the entire framework was written in Swift. We even get code completion for the delegate method here. Media View Controller did choose new media type. And now that we have all of this set up, it's really easy to add an attachment to the currently selected item. So here we say that its attachment is going to be a new attachment that we create now by calling alloc init with data. Wait a second, we defined this attachment class in Swift, and it had an initializer named init data type. But in Objective-C, it's showing up as init with data type. So you see that this name translation works both ways. So you have a consistent world in Swift and in Objective-C. I'll do a bit of housekeeping here to make sure that we update our backing store. And now we have everything set up here. All that's left to do, just like Dave did, is set ourselves as the delegate for the Media View controller. So this starts off the same, where we set the attachment and we set ourselves as the delegate. And then we can also set the title of the new view controller and make sure that it's showing the attachment that's actually on the selected item. Or if the selected item does not have an attachment, make sure that the controller isn't showing anything. So with that, everything should be working. Let's build and run. So let's go into the Tech Toys section here. And you see now we have these disclosure indicators on each of the items. If I go into Thunderbolt Display, then I can see it says no attachment. But I can click this Edit button using the view controller from the Media View framework. That brings up a standard iOS control, making sure that our privacy is protected. And this kid looks like he'd really enjoy a Thunderbolt display. OK, we can go back to another one of these here. Managed to get myself stuck editing. There we go. And you can see that the image actually does persist in the Thunderbolt display section. So it looks like everything's working. So you saw how easy it was to not just deal with a new model object, or sorry, not just a new object in your application target, but also a new model object in your framework. Additionally, this is not related to Swift at all, but in iOS 8, we now have embedded frameworks. And Xcode 6 will handle all the details of that for you. Yes, clap. Finally, once again, we updated our interface and adopted a delegate protocol. And once again, I want to impress on you that it's exactly what we would have done had the delegate protocol and the view controller been implemented in Objective-C. We didn't have to do anything unusual or different because it was implemented in Swift. So you see how easy it is with Xcode 6 to use user frameworks. And in general, we want you to be treating those the same as we do system frameworks. So that means in Swift, you'll be using import myFramework. And in Objective-C, you'll be using @import myFramework, semicolon. In general, we do want you to be using @import instead of #import. For Swift, for frameworks containing Swift code, this is absolutely required. But even for other frameworks, if they've been built with Xcode 6 and have the defines module build setting turned on, which is on by default, then you'll have a framework ready for use in Objective-C or Swift. The only reasons now to use #import are if you are working with an older framework that has not yet been rebuilt with Xcode 6 and the defines module setting, or if you're working with C++, which does not yet support the modules feature we introduced last year. So with that, everything seems to be working and our walkthrough is complete. I'd like to hand it back to Anders.
Thank you, Jordan. So, over the past hour, we've seen several different ways of mixing Swift and Objective-C. Swift is a better, safer way to do Cocoa development. It was designed to support the Cocoa frameworks, the Cocoa Touch idioms, and the common patterns that we already know. It's still Cocoa and Cocoa Touch on iOS. So that means that the knowledge and experience that you've gained over the years and the code you have applies to Swift as well. And as we've seen, some of the patterns, such as optionally calling a delegate method, are much easier in Swift and much more succinct. And in other cases, you've seen how Swift makes us define our intentions much more clearly, which can help save us later on so we don't just accidentally message nil or message an object of the wrong type. And another thing that I hope you've seen here is we've put a lot of effort into making sure that Xcode takes care of the details so that when you're using Objective-C, your Swift code looks like Objective-C, and when you're using Swift, the Objective-C code looks like Swift. And you saw some examples of subclassing Cocoa Touch classes, but that equally applies to your own classes as well. So for more information about this, there is, of course, the Swift book, the iBooks bookstore, but I'd also especially like to call your attention to the Using Swift with Cocoa and Objective-C document that we have on developer.apple.com. It's available as a PDF file that you can download and read on your favorite iOS device. And it goes into a lot more details about this. There are several related sessions. One of them has already been, but it's on video. It's the introduction to Swift, of course. Later on today, there's going to be a session on Swift interoperability in depth, and that goes into more of the language details of how to mix Objective-C with Swift. There's a great session on creating modern Cocoa apps coming up, and another one on building modern frameworks so that you can make sure that you make your frameworks embeddable on iOS and usable from Swift. Thanks, and enjoy the rest of the week.